This is lessons 8 and 9 for forces in motion. We're going to be working with dt graphs for the next little while. Recall the following. From the lab, we found that the slope on our dt graph gave us speed or velocity. The velocity is calculated by dividing displacement by time, displacement being how far you are from where you started, and that speed is calculated by dividing distance by time, distance being how far you have traveled in that entire time period. If in class, we're going to pause the video now, and we're going to be working with a motion sensor as an introduction to the distance time graphs we will be working with in the second half of this lesson. So here's our distance time graph, and we got some object that is starting at -4 meters. And in 3 seconds, it travels to +4 meters, then it stays at +4 meters for 3 seconds, and then it travels from +4 to -4 meters in the remaining 4 seconds. So how is this possible? Well, let's consider this scenario. I've got a door, and there's some dude inside his house. Well, he is standing 4 meters inside his house. In 3 seconds, he goes from standing 4 meters inside his house to 4 meters outside his house. He looks around for 3 seconds and then is like, I'm going back inside. And it takes him 4 seconds to get back to where he originally was, 4 meters inside his house. Now, if I were to put a number line on the bottom here and make the door 0, that means he is 4 meters inside his house. So in 3 seconds, he goes from 4 meters inside his house, which is -4, to 4 meters outside his house, which is +4. Stays there for 3 seconds, and then returns from +4 to -4 in the remaining 4 seconds. Now, when I do this on paper, when I'm doing it on the assignment, if I look at 0 to 3 seconds, the object moved from -4 up to +4, which is a difference of 8. It got 8 meters larger. And that is in the north direction because we're told distance is measured as north being positive, which therefore makes south negative. So the object moved 8 meters north. It then stayed between 3 and 6 seconds at 4 meters north, which means it didn't go forward, nor did it go backward, so the distance covered in that time period is 0 meters. Now, between 6 and 10 seconds, the object went from +4 down to -4, which is going down, or in the negative direction, 8 meters. So, in the last 4 seconds, it went back 8 meters north. Now, if I want to look at the distance that was covered, they walked 8 meters, and then they walked 8 meters, which is a total of 16 meters. If I'm doing displacement, I have to take my directions into account, and if I went 8 meters forward, then 8 meters back, that takes me back to my original position, which means the displacement over this entire 10-second interval is 0 meters. To the example, we are first asked, what is the average velocity from 3 seconds to 8 seconds? So velocity is displacement over time, and I'm going from 3 seconds to 8 seconds. Between 3 and 6 seconds, we didn't move at all. And from 6 seconds to 8 seconds, we went from +4 down to 0, which is a decrease of 4. That's 4 meters in the north direction. So our displacement is -4 meters north. And if we went from 3 seconds to 8 seconds, our time difference is 5 seconds. I punch that into my calculator, I get -0.8 meters per second north, which we would then write as positive 0.8 meters per second south. What is the average speed from 3 seconds to 8 seconds? Speed is distance over time, and from 3 seconds to 8 seconds, the object did not move, stayed at 4 meters away from 0, and then traveled from 4 meters away to 0, which was a distance of, well, -4 meters. But with distance, it really doesn't matter if it's positive 4 or negative 4, right? If I move 4 meters, that's 4 meters. So the fact that this is north doesn't matter to me at all. I just put in 4 meters. That's how far we have moved. We did not move at all, and then we moved 4 meters back. So covered 4 meters in a total of 5 seconds. That means that our speed is 0.80 meters per second. That's the same as our velocity was, because the object only moved one direction, stayed still, and then moved backwards. The only time that average speed and velocity are different is if there is a change in direction over the time period. Calculate the velocity at 2 seconds. Velocity is displacement over time, and at 2 seconds, we are right here on the graph. Now, when given a single time, we take a look to see what the slope is of the line that that time is on. So 2 seconds is on this line. So we are going to take the slope of that entire line. In fact, from 0 to 3 seconds, the velocity is the same because anywhere on that graph between 0 and 3 seconds, we have an identical slope. So I'm going to find the slope of this line by doing rise over run. So my rise is minus 4 to positive 4, that's 8. And my run is from 0 to 3, which is then 3. So my velocity is 8 meters north divided by 3 seconds. And that gives me 2.6 repeating meters per second, which when rounded to two significant figures is 2.7 meters per second north. Speed at 8 seconds. Speed is distance over time, and at 8 seconds, I'm right here on the graph. And the slope of the line at that point is that line right there. So I'm going to take the slope of that entire line to find out what the speed is at that time. And again, the speed will be the same between 6 and 10 seconds because anywhere between 6 and 10 seconds, those points are on this same line. So at 8 seconds, the speed is, we'll have to do rise, and I'm going from positive 4 to negative 4. So that is minus 8. But since it's speed, negative, positive really doesn't matter. So that means my distance is 8 meters, and the total time going from 6 seconds to 10 seconds is 4 seconds. So over 4 seconds. So the speed is then 2 meters per second. Had this been velocity, it would have been 2 meters per second south because the slope would be negative because we're going downhill. But since again it is speed and we don't care about direction, we just write 2 meters per second. Now in this scenario, we're counting by 2's time-wise, and the distance is counted by 3's. And the person starts at 3 meters behind the start line and stays there for 4 seconds. Then over the next 4 seconds, they move further back to minus 6. Then over the next 6 seconds, they move forward 3, 6, 9 meters forward. And now they're 3 meters ahead of the start line. And then they stay there for the next 6 seconds. So if we had a little graphic to illustrate this, we've got a person standing 3 meters behind the door. They stay there for the first 4 seconds. Then over the next 4 seconds, they move further back. So they are now at 6 meters behind the start line. And then, as we mentioned, in the next 6 seconds, they move 3, 6, 9 meters forward, and then they stay there for the next 6 seconds, and that takes us to the end of the time period. Average velocity from start to finish. So velocity is displacement over time, and for the first 4 seconds, did not move anywhere. In the next 4 seconds, moved back 3 meters. So we moved back 3 meters. Then in the next 6 seconds, moved forward a total of 9 meters. So moved forward 9 meters. And then did not go anywhere for the final 6 seconds. So that all happened over a 20-second interval. So if I went back 3 and then forward 9, my displacement would be 6 meters forward. And that, again, happened over 20 seconds. So 6 divided by 20 gives me 0.30 meters per second, and I rate it as the positive direction. Average speed from start to finish. So that speed is distance over time, and again, did not move for the first 4 seconds, then moved 3 meters in the negative direction over the next 4 seconds. But since this is distance, we don't care about direction. So we moved 3 meters back, and then we moved 9 meters forward over the next 6 seconds, and then stayed still for the rest of that time. And that was all over a 20-second interval. So if I moved back 3 and forward 9, the total distance I traveled would be 12 meters. And that happened over 20 seconds. And 12 divided by 20 equals 0.60 meters per second. Find the velocity at 6 seconds. Velocity is displacement over time, and at 6 seconds, we're right here on the graph, so I need to take the slope of this line. So it's rise over run. The rise is, well, I go down 3 because I'm going from -3 to -6. So the rise is -3 meters in the positive direction. And the run is going from 4 seconds to 8 seconds. So that is 4. So over 4 seconds, and -3 divided by 4 gives me -0.75 meters per second in the positive direction, because at that time we were moving backwards. Find the average speed at 16 seconds. So speed is distance over time, and at 16 seconds, we're right here on the graph. So we have to take the slope of that line, and that's a flat line. And flat lines have a slope of 0, so the speed at 16 seconds is 0 meters per second. Find the average velocity from 3 seconds to 8 seconds. Velocity is displacement over time, and we're concerned with the part of the graph going from 3 seconds to 8 seconds. So starting at 3 seconds and going to 6 seconds, we went from 6 meters to 2 meters, which is back 4 meters. Then from 6 seconds to 8 seconds, we went forward from 2 meters to 3 meters, which is then forward 1 meter. So our displacement is going to be, well, we went back 4 and then forward 1, which means in total, we will wind up 3 meters behind where we started. And that happened over, well, 3 seconds to 8 seconds is a total time of 5 seconds. So -3 meters divided by 5 seconds, our average velocity is then -0.60 meters per second. Now average speed between 3 seconds to 8 seconds. So again, speed is distance over time, and we're concerned with the graph that goes from 3 to 8 seconds. And at 3 seconds, we went from 6 down to 2, which is a change of 4 meters back. And then from 6 seconds to 8 seconds, we said that we had gone from 2 to 3, which is a change of 1 meter forward. And when we're talking about speed, we're not worried about direction. So I went 4 back, 1 forward. So I covered 4 meters backwards, 1 meter forward. That's a total of 5 meters that I have traveled, and that happened over 5 seconds. So my average speed from 3 seconds to 8 seconds is 1.0 meters per second. Find the velocity at 2 seconds. Velocity is displacement over time, and at 2 seconds, we're here on the graph, so we'll have to take the slope of the line that that dot is on to find out what the velocity is at 2 seconds. So we have to find the slope of that line. Rise, well, we go up from 4 to 6, so the rise is up 2. So up 2 meters, and our run is going from 0 to 3, which is 3, so over 3 seconds. 2 divided by 3 gives us 0.6 repeating, so our velocity is 0.67 meters per second in the positive direction. Final question, and something different than what we have seen so far. We're being asked, what is our location at 8 seconds? Well, let's look at the whole scenario. We start at a distance of positive 4 meters. We then move forward until we hit a location of 6 meters in the positive direction. We then start moving backwards until we hit a location which is 2 meters in the positive direction. And then we start moving forward again until we hit our final location, which is again 4 meters in the positive direction, the same spot we started from. Our overall displacement was 0 in this exercise. Now the question is asking us, over this whole time period, where were we located when we were at 8 seconds? Well, 8 seconds, this is where we are on the graph, and if I extrapolate over to the distance, we see that's at 3 meters. So at 8 seconds, we were located at 3 meters in the positive direction. That's the whole lesson. Time to start working on the FM5 assignment.